Hi everyone, welcome to my channel. This is Quantum Unicorn. The problem we are solving in this video is best time to buy and sell stock. Wow. Now let's take some time to understand the algorithm and the logic behind this code. The given problem requires finding the maximum profit that can be achieved by buying and selling a stock. To solve this, the code uses a simple approach with a simple pass through this prices array. It initializes the profit variable to 0 and assumes the buying price buy as the first element of the prices array. Then it iterates over the remaining elements of the prices array, considering each element as the potential selling price cell. For each cell value, it compares it with the current buying price buy. If sell is greater than buy, it calculates the profit sell minus buy and updates the profit variable with the maximum of the current profit and the newly calculated profit. This ensures that the profit variable always stores the maximum profit seen so far. If sell is not greater than buy, it means that the current selling price is not profitable. In such cases, the code updates the buying price buy to the current selling price, as we may potentially find a lower buying price later. After iterating through all the prices, the code returns the maximum profit that has been calculated. So that sums up the algorithm and the logic behind the code. Now let's take a closer look at each line of code. Here, the class solution object. Well, this line defines a class named solution, which serves as a blueprint for objects that can solve the problem. Def max profit self prices. Well, this line defines a method max profit within the solution class. The method takes two parameters, self, which is a reference to the instance of the class, and prices, which is the input array of stock prices. Profit to 0, well, this line initializes a variable profit to 0. It will be used to store the maximum profit. And the next line here sets the initial buying price buy to the first element of the prices array. It assumes that the first day is the day of purchase. And for sale in prices, one column. Well, this line starts a loop that iterates over the prices array, starting from the second element, and it assigns each element to the variable sale. And if sale is greater than buy, and this line checks if the current selling price sale is greater than the buying price buy. And if the selling price is greater than the buying price, and then this line calculates the potential profit by subtracting the buying price from the selling price. The max function is used to update profit with the maximum value between the current profit and the newly calculated profit. This ensures that profit always stores the maximum profit seen so far. And else, well, this line is executed when the current selling price is not greater than the buying price. It means that the current selling price is not profitable, so we update the buying price to the current selling price. And after iterating through all the prices, this line returns the maximum profit that has been calculated. The main idea behind this algorithm is to keep track of the minimum buying price buy encountered so far and continuously update the maximum profit by considering potential selling prices. By doing this in a single pass through the prices array, we can find the maximum profit achievable by buying and selling the stock. The time complexity of the provided code here is O of n, where n is the length of the prices array. This is because there is a single loop that iterates through the prices array from the second element to the last element. Therefore, the time taken to execute the loop is directly proportional to the size of the input array. The space complexity of the code is O of 1, constant space. This is because the code uses a fixed amount of additional space to store the variables profit, buy, and the loop variable sell. Regardless of the size of the input prices array, the amount of extra space used remains constant. Overall, this code has an efficient time complexity of O of n and a space complexity of O of 1, making it an optimal solution in terms of time and space requirements. Alright, that's all for today. I hope this was helpful. If you have any questions, please leave a comment, and also please subscribe to my channel, like the video, and click the bell icon on to receive the latest updates. Happy coding, and thanks for watching. Goodbye.